In this video, I'll show you how to solve the ALEKS problem called using Hess's law to calculate net reaction enthalpy. This problem is a little bit trickier than it seems like it should be. Here we've been given two chemical equations. We're being asked to calculate the enthalpy for a product of equation number 2. I'm being asked to calculate the enthalpy of the formation of 1 mole of lead 2 sulfate, which is this guy right here. We can't just simply use this equation because it's asking us to take into consideration or to include the reactants lead 4 oxide and sulfuric acid. So here's the lead 4 oxide, and here's sulfuric acid. And since it wants us to take sulfuric acid into consideration in this calculation, that means we also need to take this delta H value into consideration as well. And so we've got these two equations that we're going to use together to come up with the delta H value for this particular molecule. Now, to combine the two delta H values together, we need to combine the two chemical equations together using Hess's law. And in order to do that, what we're going to need to do is take a look at our reactants of equation number 1 and our No, I said that backwards. We're going to take a look at the products of equation number 1 and the reactants of equation number 2. Products of equation number 1, reactants of equation number 2, and we need to find the molecule that is present as a product of equation number 1 and a reactant of equation number 2. So we need to find the one molecule that is here and also here. You can see that we have water only in equation number 1, lead only in equation number 1, lead 4 oxide only in equation number 1. This SO3 molecule is the molecule that these two equations have in common. Now, once we have found that molecule, we need to make sure that this molecule has the same stoichiometric coefficient in both of these equations. If it doesn't, we can't add these equations together successfully. So as I'm looking at mine, I can see that I have a stoichiometric coefficient of 2 in equation number 2, and it's 1 in equation number 1. And I need both of these to have the exact same stoichiometric coefficient. So what I'm going to do is multiply everything in this first reaction by 2. As long as I do that same math to every single molecule, every reactant, and every product, this doesn't unbalance the equation, doesn't change anything. So now they both have the same stoichiometric coefficient. Now, before we move on, if whatever we're doing to the stoichiometric coefficients of this equation, we also need to do the same thing to the delta H value. If we are doubling the stoichiometric coefficients, we're doubling the reaction, we also need to double the delta H value as well. So whatever we do here mathematically, we're also going to do to delta H. Now, once we have that straightened out, once we have that figured out, and it's possible that you may not need to do this step because maybe they're both going to have the same stoichiometric coefficient, in which case you wouldn't be multiplying your delta H value by anything. Once you have that figured out, then what we can do is add the two equations together if we wanted to, but we don't have to because ALEKS is not asking us to do that. It's asking us for delta H. So we're just going to jump straight ahead to adding those delta H values together. 113 times 2 is going to give us 226 kilojoules, and we are going to add that to the negative 775. 200, and so our total or our overall delta H is going to be 2 times 113 plus that negative 775. I left the units off there. 226 minus 775 is negative 549 kilojoules. Now that still, we're not quite there. We're still not quite done because ALEKS is asking us not to calculate delta H. It's asking us to calculate delta H for 1 mole of lead 2 sulfate. So it doesn't want kilojoules, it wants kilojoules per mole. And what we need to do to get this to the correct number is divide by the stoichiometric coefficient for lead 2 sulfate. So what we just calculated here, this kilojoules, these kilojoules, negative 549, this is for the formation of 2 moles of lead 2 sulfate, not 1. So what we're going to do is divide by its stoichiometric coefficient, And again, maybe you don't have to do that. If the stoichiometric coefficient here was 1, it wouldn't be necessary, or we would just be dividing by 1. This is going to give us negative 270. So it looks like it says round to the nearest kilojoule. So negative 275 is the answer. So again, once we get this kilojoules figured out, this is whatever these kilojoules are, this is per however many number of moles our stoichiometric coefficient is. Take a look at what ALEKS wants from you. It's probably going to be 1 mole. Divide by your stoichiometric coefficient and you're good to go. Negative 275 kilojoules.